So continuing our discussion on prime factorization, what if I wanted the cubed root of 2000? Well, again, I'm going to do prime factorization. Always start with your lowest prime number and keep using that until you can't anymore. And then you go on to the next lowest prime number, 250. 2 is 125. 3 does not go into it because when I add these three together, 1 plus 2 is 3 plus 5 is 8. 3 does not go into 8 evenly, so 3 won't go into this either. So my next lowest prime number then is 5. So 5 goes into this 25 times and into this 5 times. Now, I'm done because on every left prong and the bottom are all prime numbers. So now I know I'm done. Now I need to put them in groups. So if you remember this guy I liked. So this guy, this index is our big boss that tells us how many of the same prime number has to be in each group. So 3. So I'm going to circle those and these. But once again, not all of my prime numbers are grouped. So that means that some people get to come outside. The ones that are circled have coats or blankets around them. They get to go out in the cold. And the other guys didn't put on a coat, so they have to stay inside. So again, this doesn't have an even root to it, okay? So then I take 1 from each of the groups and multiply them together, and I get 10. So this would be 10 times the cubed root of 2. And be sure you're saying this correctly. 10 times the cubed root of 2. If you are not saying this word times here, or between these two, then when we get to other things that happen in this unit, you're going to be lost. So start practicing saying this every time you have a number out front, that times whatever root. Okay, so this would be 10 times the cubed root of 2. So once again, I did these calculations on the calculator. You don't need to do this, but I just want you to see that the cubed root of 2000 is 12.599210.5, etc. And 10 times the cubed root of 2 is 12.599210.5. They're exactly the same. Again, this is like if the cubed root of 2000 were like 3/12, it's not, but if it were like that, I would never accept that as a final answer because it's not reduced. And 10 times the cube root of 2 is the reduced form of that. Okay? Let's do another example. Okay? So let's take the cubed root, and we can do any roots here, and you're going to see more as we start getting into the unit. Let's say I needed the cubed root of 5,400. So don't let the big numbers get you. Okay, 2 times, that's 2,700. 2 goes into that, 1,350. Remember, I will not let you use calculators, so practice this stuff without calculators. Now, 2 will not go into 675. So now I want to go to the next lowest prime number, which is 3. Let's see if 3 goes into that. So I add these numbers up, 6 plus 7 plus 5. 6 plus 7 is 13, plus 5 is 18. 3 goes into 18 evenly. It means 3 will go into 675. I don't know how many times yet, so I'm going to have to figure that out. Turns out it is 225. Now, once again, I need to see, does 3 go into this? So 2 plus 2 is 4, plus 5 is 9. 3 goes into 9, so 3 will go into this as well. Again, I don't know how many times, so I'm going to have to figure it out. Well, it happens to be 75. Now I'm going to see once again, does 3 go into 75? That didn't come out very nice, 75. Well, still isn't. 7 plus 5 is 12. 3 goes into 12 evenly, so 3 will go into 75 evenly. Turns out to be 25. Now, does 3 go into 25 evenly? Well, 2 plus 5 is 7. 3 does not go into 7. So 3 won't go into 25 either. So my next lowest prime number is 5. So 5 times 5. Well, I look at this, and now all on the left side and my denominator, and my bottom are all prime numbers. And once again, my big boss, my index, tells me how many of the same number needs to be in a group. So I've got 3 of these. I've got 3 of these. But I do not have 3 5s, so they are not allowed to be circled. So again, this is not even root because all of my prime numbers didn't get circled. So again, that means if I were to put it in the calculator, I'd end up with some big long decimal instead of just a whole number. So I take 1 from each group, multiply those up. Because they're all covered up, they get to go outside from the house in the cold. So 6 and then times the cubed root, because whatever we started with, it always has to be the same. And then I multiply up what's left. Do not ever circle these guys, but whatever prime numbers are left, I multiply up, and that's what goes underneath. I can go ahead and do this on the calculator again if you want. Okay, so I stopped and once again did the calculations for each of these on the calculator, and once again you can see they're the same. Let's just check this one to see how well we're doing. If we were to check this, it would have to be, well, let's just take 17.5. That's close. Means we aren't going to get all the way to the 5,400, but we should be very close if we're correct. So 17.5 times to the third. So that's 17.5 times 17.5. So 5 times 5 is 25, 35, 37, and that's 8. That's 35, 49, 50, 51, 52, and 7 and 5 is 12, and then 5, 7, 1. Add these all up. This is 5, and that's 12, 10, 15, 16, 10, 3, 2 decimal places, times 17.5, because I need 3 of them. Here's 1, 2, 3. So let me just do this really quickly. That's 25, 10, 12. That's, oops, 10, 12, 31, and 15. That's 35, 14, 15, 16, 17, 42, 43, yep, and 21, and then we get 5, 2, 603, and now we'll add these all up. So that's 5, 7, 12, 13, 6, 7, 8, 9, 10, 15, 3, 5, and then 3 decimal places. So we're not quite there, but the reason is because of all the rest of these decimals, and these decimals keep going on forever. But we're pretty close to 5,400. So we are reducing the cubed root of 5,400 to its lowest terms, which is 6 times the cubed root of 25, and we've shown that it actually works. So we're going to be doing a bunch of these in the lessons that I'll be providing for you in this unit. So I hope this helps.